metal atom in presence of ligand, that is after splitting of d orbital, right? And then we have discussed about what will be the effect of ligand electron on the metal. That means if ligand has orbital where ligand can accept the electron, then what will be the effect on the splitting? And in another way, if the ligand has a filled orbital to form a pi bond. Now, today, actually, I wanted to discuss so many things, but we don't have that much time. So I will share my notes and presentation with you. But today we will discuss about the filling of possible arrangement of d electron in the available orbital, that is to identify or to find out the microstate and then derive the term symbol, and then according to how many microstate will be associated with the particular term symbol, so that we will have the exact ratio or exact value of term symbol which will be included for that particular presentation. And according to the rules, we can arrange the term symbols so that we have the order of energy for the term symbol. Now, what is the use of all these things? I will discuss only the arrangement for electron in f orbital, because p2 and d2 were in your TYBSc syllabus. But if I will discuss F2, that means 2 electron in F orbital, then it will be also easier for you to understand for P2 and D2. So we will consider highest possible orbital available, because in F there are 7 suborbitals available. So what is the use of these term symbols and its energy? See, we have discussed the effect of
हेलो
ligand
मैम,
elect. Yes.
आपकी स्क्रीन विजिबल नहीं है।
स्क्रीन विजिबल नहीं है, लेकिन मैंने स्क्रीन अभी शेयर नहीं की है। मैं
ओके
शेयर
ओके
करूंगी तब विजिबल हो जाएगी। हाँ, अभी मैंने नहीं
ओके,
शेयर की है।
सॉरी मैम।
No, it's okay, it's okay. I am happy that you are concentrating on it, that's why you can tell me these things. But what my today's concern is, if I will share the note only, then it may be easier for you to understand. But I want to show you how we can arrange the electron in the orbitals and what are the application or what is the importance of these term symbols. Now we all know, according to the equation that is given in the theory and notes, we can find out how many microstates are possible in any arrangement. For example, in F2, we have 7 available orbitals, and according to the equation, if I will try to find out, then there will be 196 microstate is possible. Now, out of this 196, 14 possible microstate will be considered as excluded or redundant. Why it is considered as excluded or redundant? According to the Aufbau principle, that two electron, if there is a possibility to remain unpaired in the equal energy level, they will not get paired up. So according to that theory, we have 14 microstate that we have to consider as redundant microstate. Now I am trying to explain you with the help of the whiteboard, where I will explain how we can arrange the electron and how we can calculate the term symbols for the particular arrangement. Now, when we consider there is a f orbital, that means we have 7 suborbitals available, and I can now, is it visible to you? The whiteboard is visible to you?
Yes, ma'am.
Yes, ma'am.
Now, for example, I have represented that 7 suborbitals of F condition. That is a F orbital we in general consider, and they are given some values starting with the values equal to 0 will be in between, and starting with here it will be plus 3, plus 2, plus 1, 0, then minus 1, then minus 2, and minus 3. Now, as we said, we have two electrons. So, to arrange that two electrons in this given suborbitals are different. First of all, if I will consider that the electron will be arranged like this. Here, if I have to calculate what will be the total spin value, what will be the total orbital angular momentum L value, then what we have to do, can you tell me? According to this arrangement, if I were to calculate ms value and if I want to consider L value, then what will be the answer for it?
MS value is a 6.
ms value equal to 6.
6.
Anyone else?
MS value 2.
How will you calculate ms value? First of all, tell me that thing. ms value means what?
Magnetic spin quantum number.
So magnetic spin, that is total magnetic spin. Now what with the help of which value we can calculate this ms value?
Ma'am, with the help of spin quantum number and angular momentum quantum number.
So when we have to calculate the ms value, at that time we should not consider angular momentum because that will be included in this L value. So if I have to calculate ms value, then I have to consider the spin of the electron. Now here, what is the spin of the electron as per this arrangement? Total spin of the electron as per the arrangement.
0.
Why it
Zero.
is 0? The answer is correct, but why it is 0?
One will be having plus half and the other will be having minus half.
Right. So now how will can we calculate the value of ms? Just give me a second. I have to attend this call, please. Hello.
Hello.
Hi. Good morning.
मैडम તમને પહેલું મેં ઇન્વિટેશન મોકલાવી છે મળી ગયું?
Actually, my lecture is on, so I will check it out as soon as my lecture will be finished.
Fine, no
Okay.
problem. I'm
Yeah.
sorry.
Then it's okay, no problem. We are not knowing it. Na? I will coordinate with it. Okay. Thank you. Yeah. Yeah. Okay. So coming to the point, calculation of ms is according to the position of electron we are arranging. Here I have arranged one electron up and one electron down. So total S will be equal to 0 right now. Now possible arrangement of electron. Here I am writing out of the box over here. One is this, that I will arrange both the electron in positive direction. So in that case, we have to consider plus 1/2 for each. So total ms will be equal to 1. If I will present both the electrons in downward condition, downward spin, then it will be equal to -1. So we have s value equal to 0 or plus or -1. Here I have ms equal to 0. That is, actually you can say this is the value for s equal to 0, and we can consider the value of S in the calculation for the next one, that is total S, I will write down over here, equal to 0. Now I have another representation that is equal to 2S plus 1. So value of 2S plus 1 equal to 1 I have in this case. So S equal to 0, 2S plus 1 equal to 1. Now value of L equal to what?
Zero.
L. We are talking about L. Now when we are talking about L, then we have to consider this value.
6.
Right. Why it is 6? Because both the electrons are in the plus 3 subcell. So now I have L equal to 6 here, S equal to 0, 2S plus 1 equal to 1. Now when L equal to 6, then which symbol we can give to this term symbol? Whenever I have to derive the term symbol, what I can give?
RLJ value.
That J value, I want answer for J value. What will be the answer for that?
L plus S.
L plus S or L plus S or L minus S.
Right? That you are not getting my point. The symbol on the basis of the L value, which symbols we normally give?
Term symbol.
That third symbol, which terms we have to give for according to value of L?
Like SPDF, ma'am.
SP, yes, I am talking about
GS.
SPDFGH. So if right, L equal to starting with what is the value? First of all, we consider L for S, P, D,
S के लिए 0, P के लिए 1, D के लिए 2,
right? 0, 1,
And
2, 3,
4,
4,
5,
5, 6.
6.
Here G,
I.
then H and I, right? So we have L equal to 6. So I will have, first of all, it is I. Now according to 2S plus 1, the value is 1. So it will be 1I. Now got the point?
Yes, ma'am.
Now if I have to arrange all the possible electrons, that is the possible microstate for this, then what we can do? We can consider a table where I can write down the number of electrons, and then I can represent ML value, then L value, S value, 2S plus 1, and according to it, we have a term symbol. So instead of writing down or drawing a pigeonhole diagram, we will do something else over here. So it will be easier for us to calculate all these things. Now only you have to remember this thing. Concentrate on the spin, direction of the spin. So according to it, you will have S value, then you will have 2S plus 1 value, then you will have S, L value according to these values, and then you will have a exact term symbol. So now I am giving you a table. Which way we can draw a table? So that it will be easier for you to represent all the microstate. I am trying to find out if I have that table ready for you, then it will be easier for you to, and it will not consume more time. Okay, let it be. It is taking too much time. I have to explain this way only. You can do it with in your book with me, so that you will be able to calculate with me and you can understand properly. What am I am doing? You just do it in your book. Here we mention the number of electron. Here it is ml value. Here it will be L value, then S value, then 2s plus 1 value, and then we have term symbol. Now, as we all know, we have first is plus 3, then plus 2, plus 1, 0, minus 1, minus 2, minus 3. We are talking about here F2 arrangement. Now I have serial number. This is actually not electron number. We can say it is a serial number, or you can consider it as a microstate number. Number 1, as we have discussed. Now,
Ma'am,
yes,
is this that pigeon rule or something?
this is pigeon rule, but I am changing little bit, because in pigeon rule, what you are doing, you are representing electron in just a box, and then you are calculating all these values. Here what we will do, here you can able to write down all these things and term symbol within a line, this one line only. It is a type of a pigeonhole, but here we have all the values in this one table, one line only. Now, for example, I am considering first arrangement like this. One is up, one is down, but both of them are in plus 3. So, according to our calculation and explanation, our value of L will be 6, because both the electrons are in plus 3. S equal to 0, because 1 is plus and 1 is down. Total 2s plus 1 equal to 1, and your term symbol will be what? 1i, because it is 6. So SPDFGHI you follow, and here it is your term symbol 1i. Now, for example, second microstate I am considering, where I am representing one electron here up, one electron here in up direction. Now, what is the value of L?
5.
5. So, according to 5, your term will be, first symbol will be H, because if you start with it 6, 5, 4, 3, then it will be H. Now, S value equal to what? S
One.
equal to plus 1. 2s plus 1 equal to 3, and your term symbol is 3H. Now, third condition we are considering the same value, but now I will take a spin opposite. One is up and one is down. So L value equal to, again I have 5, but S value becomes 0, 2s plus 1 become 1, and my term symbol will be 1H. Right? So in this way, you can keep on trying. Now it will, you can understand that if I have to arrange all the microstate term, then I can go one by one for each, and I will have different term symbols over here. So there will be a list of term symbols. You will find it in my notes. But now we are going further. Apart from this arrangement, as I said, if I will arrange this way, instead of that, if I will say my 4 fourth arrangement is like this. What did I change? I have changed the spin of the electron. For +3 it was up. I did it in a downward, and +2 it was down. I made it in the upward direction. Now this is the arrangement possible. We are considering that this is a possible microstate. But if you come to the finding out the value of term symbol, again I will have 5, 0, 1, and I will have 1H. Now, I am not concerning about this 1H. 1H term can be arrived, or you can derive this value in any other way also. My concentration right now is here on this part. For instance, we have considered the electron 1 was up in +3 and 2 was down in +2. Then I have changed electron 1 in down in +3 and 2 is up in +2. But these both are actually the similar condition. Can you understand? ખ્યાલ આવે છે?
Yes, ma'am.
Yes, ma'am.
Right. So even if I have two different microstates, but these two different microstates actually represent a similar condition, because when we are practically observing, we cannot find out this is the electron 1 or this is electron 2. So now our out of 196 microstate, we said that 14 is abundant. Why 14 is abundant? Because when we have considered this arrangement, both the electrons are in the one cell only. So this arrangement is not possible because I have similar energy levels over here. So in that case, both the electron will not be in the same spin direction, in the same orbital. Similar way, if I will arrange both these electron in downward spin also, then also it is not advisable, not acceptable. So for 7 sub cell, both these arrangement are not possible. That's why we are saying that 14 microstates are considered redundant. That is not acceptable. Out of 196, if you deduct 14, then you will left out with how many?
182.
182. Now, out of 182, as we have discussed, there are two arrangements which are actually the similar one. So, out of this 182, for every arrangement, we have two arrangements which will be the similar arrangement. So, we will left out with 91 term symbols can be derived for the F2 configuration. Now, out of these 91 terms, which symbol will be derived, and we consider it, they will be as per the different arrangement. So, out of this 91, how many term symbols will have the similar term symbols? For example, how many term symbols will have one I term symbol? How many of them have 3H term symbols? Like that. If I have to calculate this, and without arranging the electrons like in a pigeonhole arrangement, then there are particular rules that we have to follow, and according to that rule, we can find out actual term symbols associated with F2 arrangement, and then we can go for the arrangement of energy of that terms according to the increasing or decreasing order of the terms for F2 configuration. And same way, I am not discussing that rule because it has already explained in my note, and you can easily understand what I wanted to tell in that rules, by that rules. Now, For example, we are left out with total 7 term symbols for F2 configuration, and I am arranging that term symbols. Then which rule I have to follow? In that case, first of all, the value for 2s plus 1 is the highest, that is 3. In our case, it is a 3. So that we have to consider whatever terms are there with the highest value of 2s plus 1 will be considered. Then according to next rule, I have 3h, which will be the lowest in the energy because it will be considered as the most stable arrangement of electron. Then I have 3f higher from this one. Then I have 3p next higher. Then we will have the other arrangement, that is 1i, 1g, 1d, and 1s. 1s is the highly unstable we can consider. The term symbol associated with the arrangement of electron where we will obtain 1s term symbol, that will be the most unstable arrangement of electron. The term symbol we obtain for the electronic arrangement, which will gives us 3h term symbol, that will be the most stable terms or most stable arrangement of electron, which will be at the lowest energy level. Now, this all order of these term symbols is important. In objective type of question, you will be asked which to select correct arrangement of these term symbols on the basis of P2, F2 or D2 arrangement. This is in your syllabus, P2, F2 and D2. Now, what you have to concentrate while giving the answer? First of all, the sign, that is, it will from the lowest to highest. For example, any examiner will change the order, then what you will get? 1s is greater than 1d, is greater than 1g, is greater than 1i, is greater than 3p, is greater than 3f, and is greater than 3h. So you have to remember, you have to concentrate on this part. Either it is less than or it is greater than. If it is less than, then 3h will be on the most left part. And if it is the greater than, the 1s will be over here. So concentrate on it, and depending on that, find out the answer. In another way, they will give you the different option, but this order will be jumbled. So what I will give you, for example, I am giving you 3h less than 3p less than 1i less than 3f less than 1g less than 1s less than 1d. So this is not the correct answer. So remember this thing, HFP, because when we are starting with this arrangement, you have to remember this order of the terms, and according to it, you will be able to give the answer for it, right? Now the next, once we will have the different energy for the different terms, how it will help us, and what if I have these values, what I can predict or how I can use it. For that, number one, the electronic spectra, that is important part. We have derived these energies, we have derived these term symbols in presence of ligand or absence of ligand. That is the one important point. What we have derived right now, that derivation of term symbols is in absence of ligand, because we have just considered the possible arrangement of electron in the metal orbital. Energy of these term symbols also we have calculated, or we have find out for the metal ion only. In gaseous form, normally it practical has been performed, but in presence of ligand, it is possible that these term symbols will have the different energy. So the spectra, electronic spectra, is the tool which gives us the proper understanding for the change in energy of this term symbol. That means the arrangement of electron in presence of ligand, where it will be repulsion for also important part. Now here, when we consider metal atom, at that time repulsion from only internal electron of metal is possible. So just remember, for example, I am considering one metal atom. For example, it is M1, metal atom 1, which has 2 electrons in its f orbital. So here, these 2 electrons will have repulsion internally. So it is internal repulsion only. Now in this case, repulsion between the electron for the metal will be affected by the presence of ligand. Now, how it will be affected? Either the repulsion will decrease or repulsion will increase. For that, I am considering a schematic diagram. Earlier, metal has one f orbital. For example, it has this type of space available for these 2 electrons to move along. So what I have here electron 1 and here electron 2, which can move within this space. Now, as soon as this ligand orbital will combine with the metal, what will happen? We have this combination of orbital. Now, this combination of orbital, when we are representing, actually what is happening? Maximum overlapping of this or both the orbital will give actually this much space for electron to move. Now understand properly why I am saying this. Earlier we have considered metal orbital where 2 electrons have this much space to move around. They cannot go out of this space. As soon as the ligand orbital will combine with it, now here ligand orbital may have electron. So I can represent that number 3 electron is there with the ligand. There are total 3 electrons now. But what is changing? Now for these 3 electrons have total this much space to move around. So each electron will have more space to move. That's why the inter-electron repulsion in metal earlier will be higher compared to in presence of ligand. So repulsion will be decreased due to the presence of ligand, and as the repulsion will decrease, the whole structure will be stabilized. That is the importance of consideration for this ligand orbital intervention with the metal and the effect of ligand electron onto the metal electron. So number 1, repulsion between electron for the metal will be higher in absence of ligand, but it will be decreased in presence of ligand. Now, the energy states also will be affected with the spectral arrangement, that is octahedral field and tetrahedral field and so on. But for example, if I will consider octahedral field only, then also we have the arrangement of P2G and EG orbital, and the splitting of it also will have the effect of ligand. So all this character, all this parameter will affect the actual energy level diagram, and that will be represented, and that will be helpful to understand the repulsion energies. Now, to represent the energy of different state for various field strength and electron repulsion energy are known or derived by Tenaber-Sugano diagram, and it is a correlation diagram which can explain or depict the energy of electronic state of complex as a function of ligand field, strength of ligand field. So that diagram related with the presence of ligand or field of ligand and the arrangement of electron. So if I have to explain or I have to understand the actual electronic spectra, then depending on this repulsion parameter, two other terms will be involved, and first term involved, that is Raka parameter. Now Raka parameter is actually the values or what parameter we will obtain due to the repulsion of electron, and normally we represent that Raka parameter as A, B and C. These three part representation always will be there for which term symbols. If we consider the highest term symbol, that is term symbol with the higher energy, then this C value will be there. But if we consider the lower, that is stable term symbol associated with the arrangement, then only two parameters A and B will be there. So this C represent actually the repulsion due to the interaction with the ligand orbital, and the excited state. So according to this Raka parameter, it is easier to express the energy of the term symbol in form of this parameter for different metal complex, for different metal atom. It may be evaluated and they may have the different values, but for every condition, for every metal complex, only we have to remember this thing, that the lowest energy term symbol with the highest value of 2s plus 1, remember this part, highest value of 2s plus 1 and the lowest energy term symbol will have these two parameter only, and rest of the all the term symbol will have three Raka parameter A, B and C. Now depending on this, as we have discussed, the in presence of ligand, the inter-electron repulsion decreases, and according to that we can arrange the different ligands that will affect the repulsion, and that is known as the nephelauxetic series, or we can say cloud extended effect. Cloud extending effect, what I have explained over here, that is the expansion of available space for the electron to move around, that is represented by nephelauxetic series. And that nephelauxetic series also may have kinetic value that is represented by the symbol beta. So B and beta are different things. Beta is associated with the nephelauxetic series and this B associated with Raka parameter. So with this I am completing my lecture. I will share my note and presentation by today evening, so that you may have different question or answers able to find out from that. And even if you are not able to find out the answers from that note, you can anytime send me a message or mail, and I will explain that part to you, or I will give where you can get this answer. Okay, so now, you have any question?
No, ma'am.
Okay, so no doubt all this part included in TY, but your TY BSc study was in online course, so I am not aware how many of you have actual access to all these things. So I have given everything starting with the P2 and D2 also. I have given in my note the arrangement of electron and all this, so it is self-explanatory. So go through it and then try to understand. So bye for now. We are ending today's lecture over here.